Hello friends, today we are going to start a new chapter, that is coordinate geometry, chapter number 7. We have already studied this concept of coordinate geometry in standard 9 also. How to plot a point in a different quadrant. You know there are 4 quadrants. First quadrant, the x coordinate and y coordinate is positive. So you can divide a coordinate plane in 4 parts, and this is known as first quadrant. This one is known as second quadrant, while this portion is known as third quadrant and this portion is known as fourth quadrant. Now, any point in the first quadrant, the x coordinate is also positive, y coordinate is also positive. Here, x in this direction is negative and y in upward direction is positive, and that's why the coordinate of any point in the second quadrant is minus and plus. X-axis in left hand side is negative, y-axis downward is also negative, and that's why any point in the quadrant 3, first coordinate is negative, second coordinate is also negative. Similarly, in fourth quadrant, x-axis right hand side is positive, y-axis in downward direction, that is negative. So this is first quadrant, second quadrant, third quadrant, fourth quadrant. You can divide a plane into 4 quadrants. And the intersection of this y-axis and x-axis is known as origin. And the coordinate of origin is 0, 0. We have already studied this in 9th standard. Now in 10th standard we have to use this concept in many examples. Well, suppose any point on x-axis. Suppose a point A on x-axis. Suppose this is 1, 2, 3 and 4. How to write the coordinate of this point? On x-axis y coordinate is always 0. Here x coordinate is 4. So the coordinate of point A is 4, 0. So we have studied this in 9th standard that any point on x-axis, y coordinate is always 0. Now any point on y-axis, suppose one point B is there on the y-axis. Suppose it is 1, 2, 3 and 4. So on y-axis, x coordinate is always 0. So the coordinate of point B is 0, 4. If you write any point on x dash axis, means OX dash, means in the left hand side of x axis. For example, 1, 2, 3, the point number 6. Here on x axis, y coordinate is 0 and x coordinate is minus 3. So the coordinate of point C is minus 3, 0. So one very important conclusion, that is a point on x-axis, y coordinate is always 0. A point on y-axis, x coordinate is 0. The intersection of these two axes is known as origin. And in first quadrant, both the coordinates are positive. In third quadrant, both the coordinates are negative. In second quadrant, x is negative while y is positive. In the fourth quadrant, x is positive and y is negative. Now here in this chapter we are going to start the first concept of this chapter. There are only 4 concepts in this chapter. The name of the first concept is distance formula. Means in a coordinate plane 2 points are given to you. How to find out the distance between 2 points? So the first concept of this chapter is distance formula. Suppose A x1 y1 and B x2 y2 are 2 points in a plane. Then distance AB can be defined by, for example, in a plane, 2 points are given to you. The name of the first point is A, the coordinate are x1, y1. Another point is given to you, that is B, the coordinate of these points are x2 and y2. Now if you join this 2 point AB, and this is known as what, line segment AB, so you can find the distance between these 2 points and it is denoted by AB, or you can say distance between point A and B. It has one formula. So how to find out the distance? AB is equal to under root x1 minus x2 square plus y1 minus y2 square. Well, x1 y1 is a coordinate of first point, while x2 y2 is a coordinate of second point. So your formula is AB is equal to under root x1 minus x2 whole square plus y1 minus y2 whole square, and it is denoted by AB, or you can also write distance between A and B. So your first exercise number 7.1 is on the basis of distance formula. Very simple formula. Coordinate of 2 points are given to you, and from this coordinate of these 2 points you have to find out the distance. So AB is equal to under root x1 minus x2 square plus y1 minus y2 square. You can draw a figure ax1 y1, bx2 y2, and this distance is denoted by AB, and its formula is equal to x1 minus x2 whole square plus y1 minus y2 whole square. So this is your first concept of this chapter number 7, that is coordinate geometry. So let us start to solve some example. Only first 3 illustrations are there in your examination, and first 7 examples of exercise 7 point is also there in your examination. So there are only 10 examples, 3 illustration and 7 example of exercise 7.1. Only 10 examples there on the basis of the distance formula. So let me start illustration number 1. Do the points 3, 2, minus 2, minus 3 and 2, 3 form a triangle question mark. If so, name the type of triangle. So here you have to use 2 concepts. The concept number 1, condition for the formation of triangle. 3 points are given to you, and you have to check whether they form a triangle. You know, we have studied one concept in 9th standard. If the sum of 2 sides is greater than the third side, sum of any 2 sides is greater than the third side, then we can say that these 3 points form a triangle. So this is the necessary condition for formation of a triangle. You know, there are 3 sides in a triangle. So you have to find out the distance of 3 sides. Suppose let me consider these 3 points are P, Q and R. So P 3, 2, Q minus 2, minus 3 and R 2 and 3. So here you have to find out the distance PQ, distance QR and distance PR. The sum of 2 distance is greater than the third distance. Then we can say that they form a triangle. Otherwise, these 3 points do not form a triangle. So to prove this, first of all we have to find out 3 distance. That is PQ, QR and PR. So let me find out PQ. Again you have to use this formula to find out the distance between 2 points P and Q. So the coordinate of P is 3, 2 coordinate of Q, they are -2 and -3. So PQ is equal to x1 minus x2 square plus y1 minus y2 square. x1 minus x2 square. So 3 minus -2 मतलब 3 plus 2 whole square plus 2 minus -3. So 2 plus 3 whole square. 3 plus 2 5 square 25. 2 plus 3 5 square 25 under root 50. If you find out the square root of 50, you get 7.07. Approximate value is there. Similarly, find out QR. This is your x1, y1, x2, y2. So x1 minus x2 whole square means -2 whole square means -4 whole square means 16. Similarly, -3 whole square means -6 whole square means 36. And 36 plus 16 is equal to under 52. If you find out the square root of 52, you get 7.21. This is approximate value. Similarly, find out the distance PR. x1, y1 means 3, 2. x2, y2 means 2, 3. Formula is under root x1 minus x2 square plus y1 minus y2 square. So, 3 minus 2 whole square plus 2 minus 3 whole square. 3 minus 2 1 square means 1. 2 minus 3 minus 1. And the square of minus 1 is also 1. So minus 1 square is also 1. So it is under root 2. If you find out the square root of under root 2, it gives you 145. You know, if you add two things, for example, 7.07 plus 7.21 is always greater than 1.41. Now if we add first and second, so 7.07 plus 1.41 is always greater than 7.21. Similarly, 7.21 plus 1.41 is always greater than 7.07. So the measure of sum of two sides is greater than the measure of the third side. So from this we can conclude that it form a triangle because sum of two sides is greater than the third side. So, do the points form a triangle? Yes. So they form a triangle due to this condition. If so, name the type of triangle. So here there is another question. You have to write type of triangle. You know, on the basis of angle, you can write it is a right angle triangle, or you can say acute angle triangle, or it is obtuse angle triangle. So this triangle may be acute angle triangle, obtuse angle triangle, or right angle triangle. If we talk about side, we can say it is scalar triangle. All the three sides are different. If three sides are same, then we can say equilateral triangle. If any two sides are same, then we can say isosceles triangle. So you know the three sides are not same, so it is not equilateral triangle. Even the two sides even not same, and that's why you can't say it is isosceles triangle. You can say the three sides are different, so you can say scalar triangles are there. So on the basis of side, you can say it is a scalar triangle because the length of the all three sides are different, and that's why it is known as scalar triangle. Similarly, if you find out on the basis of the angle, you know, if you find out the PQ square means under root 50 square, it gives you 50. Let me find out QR square. So QR square is equal to under root 52 square is equal to 52. Now let me find out PR square. PR means under root 2 whole square means 2. You know, if you add this to PQ square plus PR square is equal to QR square, because 50 plus 2 is equal to 52. So in a triangle, PQ square, suppose this is 50 and PR, this is 2 and this is 50. So PQ square plus PR square is equal to is equal to QR square, and that's why we can say that according to the Pythagoras principle we can say that it is a right angle triangle. Here measure angle P is equal to 90 and QR is a hypotenuse. So on the basis of side, this triangle is known as scalar triangle. On the basis of angle, we can say that it is a right angle triangle because it satisfies the condition of Pythagoras principle, that is sum of the square of any two sides is equal to the square of the third side, and that's why according to the Pythagoras principle it is a right angle triangle. Well, so we have completed illustration number 1, how to find out the distance, then how to check whether it form a triangle or not, and then we have discussed type of triangle on the basis of the side as well as on the basis of the angle. Well, now let me start illustration number 2, so that the points 1, 7, 4, 2, -1, and -4 are the vertices of a square. You know the characteristics of a square. All the 4 sides are same. Diagonal even are also same. So let me give the name. For example, A is 1, 7, point B is 4, 2, C the coordinates are -1, -1, and D the coordinate are -4 and 4. So first of all, let us find out the 4 sides of this square or this figure. So first of all, find out AB. So AB is equal to under root. You know the formula, x1 minus x2 whole square plus y1 minus y2 whole square. So x1 minus x2 means 1 minus 4 whole square plus 7 minus 2 whole square is equal to under root 1 minus 4 minus 3 square means 9 plus 7 minus 2 5 square means 25. So 25 plus 9 is equal to under root 34. So we can write AB square is equal to 34. Now let us find out BC. B and C. So here you can write 4 minus 1 plus 1 whole square plus 2 plus 1 whole square. So 4 plus 1 5 square means 25 plus 2 plus 1 3 square means 9. So again you get under root 34. So you can say BC square is equal to 34. Similarly, find out CD. C and D. -1 minus 4 means -1 plus 4 whole square plus -1 minus 4 whole square. 1 minus 1 plus 4 3 square means 9 plus -1 minus 4 minus 5 25. So again you get 34. So CD square is also 34. Let me find out AD. A and D. So 1 minus 4 means 1 plus 4 whole square plus 7 minus 4 whole square. 7 minus 4 whole square. It gives us 1 plus 4 5 square 25 plus 7 minus 4 3 square 9. Again you get under root 34. So AD square is also 34. So from this 4 point we have concluded the 4 sides formed by these 4 points, they are equal. When 4 sides of any quadrilateral are equal, it may be either rhombus or a square. But here you have to prove that these 4 points are vertices of a square. So if you consider these 4 points A, B, C and D, here it is known as what? Under root 34. This is under root 34. AD is also under root 34. CD is also under root 34. Now find out AC and BD. If it is a rhombus, then diagonals are not equal. So let us find out the diagonal. If both the diagonals, that is AC and BD, are same, then we can say that it is a square. If the two diagonals are not same, then we can say that the given figure formed by this 4 point is not a square. So now you can distinguish how to prove whether these 4 points are a point of a square or a point of a rhombus. 4 sides are equal means it is either square or either rhombus. Let us find out diagonal. If diagonals are equal, we can say that it is a square. So first diagonal is AC. So AC is equal to under root A and C. So 1 minus 1. So 1 minus minus 1 means 1 plus 1 square plus 7 minus minus 1 means 7 plus 1 square. So is equal to 2 square means 4 plus 7 plus 8. 8 square means 64. So it is under root 68. Similarly, another diagonal is BD. How to find out BD? So B means 4 2 and minus 4 4. So 4 minus minus 4 means plus 4 whole square plus 2 minus 4 whole square is equal to 4 plus 4 8 square 64 plus 2 minus 4 minus 2 square again 4. So you get under root 68. So here BD is also under root 68, AC is also under root 68 and 4 sides are common. So AB square is equal to BC square is equal to CD square is equal to AD square. This is the first condition, and AC square is equal to BD square. So points A, B, C and D form a square. So this is the conclusion of this second example. So here you have to prove that it is a square. So for square there are two conditions. Now the condition number 1, all the sides should be same and the diagonals should be same. If it is a rhombus, suppose in some example they ask prove that these 4 points are 4 points of a rhombus. Then again the first condition is 4 sides are same. Second condition is diagonals are not equal. Suppose in some example they ask so that these 4 points are points of a rectangle. So opposite sides are then AB and CD are same, BC and AD are same, opposite sides are same and diagonals are equal. Then it is known as what? Rectangle. If opposite sides are same and diagonals are not equal, then it is known as parallelogram. So along with this example, we have also understand another 4 example how to prove 4 points are a point of a square. How to prove that the 4 points are a point of a rhombus. Similarly, how to prove the 4 given points are points of a rectangle as well as a parallelogram. So here nothing but you have to use 4 sides, and for this you have to use distance formula. Similarly, you have to use diagonals. Again you have to use distance formula. So with the help of distance formula, you can find out the distance between 2 points. You can check whether the given triangle is isosceles triangle or a scalene triangle or equilateral triangle, or you can also prove whether a acute angle triangle or obtuse angle triangle or right angle triangle, and you can prove whether the 4 points are square or a rhombus or a rectangle or a square. Well, so there are only 3 examples of illustration 3 and 7 example of exercise number 7.1. Today we have understand the concept of distance formula, as well as we have solved first and second example. Along with second example, we have solved another 4 example. Then and it will describe so that the points are the vertices of a square, vertices of a rhombus, or vertices of a rectangle, or vertices of a parallelogram. Well, in next period, we will start third example as well as first 7 example of exercise number 7.1. Thank you, friends. Thank you.